Okay, so solving quadratic functions, square root, some of the basic fundamentals. You're thinking, okay, what about squaring a number? Okay, what does that equal to? Well, let's just look at 2 squared being equal to 4, right? Let's look at 4 squared being equal to 16. Now let's add a variable to that and say, okay, if you want to solve for a variable and set it to an integer like 4 or a perfect square like 4, or if x squared is equal to 16, if this is something you're solving for, well, in order to get rid of a square, something squared, you take the square root. You take the square root. And that's the same thing, x is equal to 2, x is equal to 4. That's the same thing as me doing 3 plus 3 minus 3, or 3 times 3 divided by 3. These are inverse operations. X squared to the square root of x is just x. Now what you'll see with some is that you'll see, okay, x squared is equal to 25, let's say. And then you take the square root, and you'll see x is equal to plus minus 5. Plus minus 5. What is that? Well, the understanding that is if I put in a negative 5 for x, or a positive 5 for x, I'll get the same result. Negative 5 times negative 5, 5 times 5. Both negative, negative, positive 25, negative, negative 20, or I'm sorry, positive, positive 25. That's where that plus minus comes into play, right? Now let's say you end up getting a result of 4 square root of 2, or let's just say you end up with a result, and because you'll see this where you end up with a square root on the bottom, just as a fundamental, right? You can't leave a square root on the bottom because technically it's like an irrational number. It's something that we consider to be never-ending, non-terminating, non-repeating, almost like it's not a real number. So what we want to do is conjugate and get the square root off the bottom. So I multiply across 4 square root of 2. Square root of 2 times square root of 2 is actually square root of 4. And square root of 4 is 2. So you actually end up with 2 on the bottom. This I can reduce like it was 4 over 2 as a fraction. So actually I can reduce this to 2 square root of 2. This is a good fundamental to know because you're going to see this when we go over some examples. So let's look at a couple examples with some added parts to it, like 2x squared minus 63 equals 0, right? Now again, we're trying to solve for x. This is solving quadratic functions. This is using square root rule. This is using conjugate. I want the x by itself. First thing I want to do, plus 63, plus 63. 2x squared is equal to 63. With me so far? The 2 is multiplying, so I divide. X squared is equal to 63 over 2. Now we talked about, we explained that if you're trying to get x by itself and it's squared, we want to take the square root, and this is what's going to get x by itself. We've done an inverse operation. This is multiplying, we do the inverse, we divide. This is squaring, we do the inverse, we take the square root. So you're left with x is equal to square root of 63 over square root of 2. I think this is called the quotient rule, where you have something like this, and you can split it into 2 radicals. Now there's a couple other pieces here that we have to look at. One being the fact that square root of 63 can be broken down into square root of 9 and square root of 7. This radical can be simplified. And right away we see a perfect square. Okay, we see square root of 9 as a perfect square. Square root of 9, 3. 7 prime number, can we break this down? No, this stays square root of 7. And then square root of 2. Now we talked about the fact that we can't have a square root on the bottom. So technically what we're doing is we're conjugating with square root of 2 over square root of 2. Now, this is like parts I can combine and I can multiply. So it would be like if I had 3x times x, this would be 3x squared. I can only multiply the variables. Same thing here. 3 times 7 times 2, 14. Square root of 2 over times square root of 2, we just talked about with square root of 4. So that actually gives me a 2. And this would be my final answer. Now, we talked about here that when you take the square root of something, technically it's plus minus. Right? You're saying I'm taking the plus minus version of that. There's a plus minus version. I mean, there's two versions I can put into a parentheses and square it. So we could say it's plus 3 square root of 14 over 2, and we could say it's a negative 3 square root of 14 over 2. That's a good example to look at. We could look at, I would like to look at this as an example, where you have some parentheses. This is a little bit different. I like this because what you're actually doing here is this square is actually squaring the entire quantity. So you're basically taking the square root of this whole piece. So I've actually simplified this to 4x minus 2 is equal to 5. Or we could say plus minus 5. Right? We could say plus minus 5. So I could say 4x minus 2 is equal to 5, or 4x minus 2 is equal to negative 5. Add 2, 4x is equal to 7. 4x, add 2. This is negative 5 plus 2, so this is actually negative 3. Divide by 4, x is equal to 7 over 4, or negative 3 over 4. You see how those two answers. And that comes from the idea that square root of 25 is really actually 5 or negative 5.